Hi guys, welcome to Maths Cube. Today we are attempting physics unit 1 paper, mechanics and materials, and this is a new spec paper from October 2019. So without further ado, let's get started. So the first question states that which row of the table gives the meaning of the stated unit prefixes. One column is for micro and one for centi, and I'll be labeling these stated unit prefixes now. There you go, 10 to the power minus 6 is micro and 10 to the power minus 2 is centi, and we can clearly see that our answer is A. That's it. 10 to the power minus 9 is not the answer. 10 to the power square is not it. Yep, the other options are not valid. Moving on to the second part, all quantities may be expressed in terms of SI base units. Which of the following are base units for moment of a force? So what we'll do is always write the formula out. So moment is equal to force into distance, and force can be written down as kg into meter per second square, and d can be written out as, and when we multiply them we will get kg into meter square into second per square, and then clearly see that B is our answer. It's not D clearly, and that's not A clearly, because A is for force and force equal to ma, so kg meter per second is for ma. So B is our answer. The third question states that a student measured the diameter of a length of wire in order to determine its cross-sectional area. The following measurements were taken at various positions along the wire at various orientations around the wire. All measurements are in millimeter. Which of the following expressions should the student use to determine the cross-sectional area of the wire in millimeter square? Always guys, first things first, always write the formula down. So the formula is A equal to pi r square, and these values are given in diameter. So what I'll do is, first we will take the mean. So before even attempting to take out the mean, what we can see is, we can clearly see that 1.36 is an anomaly, because it's not even close to the values at 1.57 and 1.54 are. So now we are left with 4 total values. So when we add these 4 values we get 6.24, and to get the mean we'll divide it by 4, and it will give us a mean diameter of 1.56. and remember guys, we are dealing in radius here because the cross-sectional area formula consists of a radius. So what we'll do is we'll just divide 1.56 with 2 to get radius, and we'll get a radius of 0.78, and we can clearly see that our answer is C. That's pi into 0.78 into square. Moving on to the fourth question, the area under each of the following graphs represents a physical quantity. For which graph is the area under the graph not equal to work done? So it's not now, and we can see that force displacement graph does show work done under the area, so that's work done here, so that's not the answer. And force upon extension graph, yep, that shows a work done under the graph, so that's not either the answer. And power upon time do show a work done under the area graph, so that's definitely not the answer. But basically, if you do know that stress upon strain, the graph, the area under the graph shows Young modulus as the area under the graph, so that's D, and D is our final answer. The fifth question states that the steps on this escalator move with a speed of 0.5 meters per second. The vertical component of their velocity is 0.3 meter per second upwards. Which of the following is the horizontal component of velocity for the escalator steps? So how to approach this kind of question? There in the question you can see there's been a hint that's horizontal component. We have to find horizontal component, and whenever horizontal component pops up you have to remember that we have to use cos, and we know that a cos function is adjacent upon hypotenuse, and we have to find this component here, and that's our y basically, or you can say that's x, because we are dealing with x. So what we can do is we can use Pythagoras theorem to find the y value. Basically the Pythagoras theorem is a square plus b square equal to c square, but for your reference I'm using y here, so that's a square plus y square equal to c square, and plugging in the values here we'll do some quick maths and take 0.3 square to that side, so we'll get y square equal to 0.16, and to get y we'll square both sides and we'll end up having y equal to 0.4, and we can clearly see B is the answer, and that's how you solve this. horizontal component or vertical component questions. Moving on to the sixth question. Okay, question 6 and 7 are referred to the diagram below, so they are merged. So 6 and 7 are both of one question combined. A uniform solid cube is placed on table. The diagram shows the forces acting on the table and on the cube. These are the forces shown, and the question says that the dot at the start of every arrow line indicates a point at which the force can be considered to act, and which of the following forces has been drawn in the wrong position. Okay guys, common sense here. Okay, we'll look at the RC, or normal force for the cube, and that's okay. It's not the table RT, which or reaction force of table on cube. That's okay. We'll look at C, the weight of the cube. It's given in the middle line, so that's the wrong position there, and that's the answer. If we even look at the last option, that's weight of the table, and that's right, so that's our answer. C is the answer. The seventh question is, the table has 4 legs. Which of the following statement is correct according to Newton's third law? Okay, fine. Newton's third law is when an object is being given a force, external force, it pushes back in the same direction. Okay, A part does not even make sense. Okay, Newton's third law, I guess it's related to normal reactions. If it is, then yep, C is the answer. Eighth question says that an electric pump lifts water from a well through a height of 10 meters at a rate of 4 kg per second. The water leaves the pump with velocity of 5 meters per second as shown. Okay, water is lifted up and then lifted down and leaves the pump at 5 meters per second. The question is, which of the following expression could be used to determine the minimum power output of the pump in watts? So guys, we are dealing with power, so it relates to energy, and we have to deal with or we are assuming that all of the energies are being conserved and all of the energy is being considered. So I guess both kinetic energy and potential energy is being considered. So to find the minimum power, it goes up and goes on. This won't be the answer. This will be only potential energy. That's not the answer. Okay, C and D are close, but that's a minus sign, and we are not cancelling each other out, and we are adding it, so that C is our final answer. Ninth question says that a student used the following sphere to determine the acceleration of free fall. A camera produced images of sphere at constant time intervals as it fell. The position of the sphere in first 2 images are shown. Image 1 shows the sphere's position at the instant it was released. Okay, those are the 2 images, and then some alphabets P, Q, R, S. Question is, which of the positions P, Q, R and S will the sphere be at in image 3? So guys, we need to find out the location where the image 3 will be allocated with the alphabet. What I guys want to know that when we talk about acceleration and free fall, we have to consider the terminal velocity, and the terminal velocity is when acceleration due to gravity gets close to 0 and it falls freely. So I guess image 3 won't be at P, so I'll just cancel it out, and it won't be at S, it won't be traveling at that fast, but it should be around R. I guess it should be here if it falls with terminal velocity. So I guess C will be our final answer. The final question, a force F was applied to compress a spring by distance x. A second spring of double the stiffness was compressed by the same distance x. Which of the following gives the magnitude of force applied to second spring? The question is talking about Hooke's law, so let me write the formula out. So that's the formula we'll work it. Force equal to minus K. K is the proportionality of the spring and x is the extension. We'll ignore the minus sign. It says that a second spring of double the stiffness was compressed by the same distance, so the extension goes double. They ask us what happens to force. We should be familiar that force is directly proportional to the extension. So when extension doubles, force will also double. So our answer will be B, that's 2F, and we are done with the MCQs. I hope you find my method of working great. If you like the video, do subscribe and stay tuned for more videos like these.